The first thing to say is I feel like an interloper at somebody else's wedding, because I'm the only one here for whom Haxe isn't my first love, because I've really fallen in love with the Go language, and Haxe is just my sweetheart on the side. So thank you all for making me welcome. People have come up to me and said, "You're the Go guy." So thank you all, thank you. What I want to talk about is Haxe as a compilation target, and I think this is a new use case for Haxe. I think there are lots of compiler writers out there, especially people who want to invent new languages, where they'd really like to have a compilation target which would allow them to immediately get to lots of other places. And I think Haxe holds that possibility. The other thing someone kindly said to me last night was, "You're the oldest person in the room," which may be true, but frankly I wasn't ready to hear, because I'm young, damn it, young, I tell you. But just to point out how old I am, I'm a Doctor Who fan, and I actually watched the first episode. And then around 10 years later, I wrote my first computer program, which was on punch cards in Fortran when I was at school. And then a few years after that, I went into becoming a manager. And then a few years after that, after being a programmer for many, many years, I eventually stopped programming and stopped managing IT people and did all sorts of other stuff. And it's only in the last year that I've actually come back to it. And I looked around for languages that just excited me, made me interested. And I have to say that Go and Haxe are the two languages that I want to work in. And I've not come across any others, frankly, that I do want to work in. So, on the Doctor Who theme, I hope you all know Doctor Who, I think Go is like the TARDIS, really, because when you look at it, it looks disappointingly small. But inside, there's actually a lot of stuff going on. And if you take the time to walk inside the TARDIS, you'll find that there's quite a lot there. Whereas Haxe is more like Doctor Who's sonic screwdriver, because if there's a problem, it's almost certain that Haxe is the solution, much like... Okay, so what I'm going to talk about today. First of all, I want to just introduce Go, and I know this is a Haxe conference, so I'll do it really quick, and I'm only going to do the parts of Go that are sort of germane to what I want to talk about. Then I'll talk about the transpiler I've written, then some issues with that, and I have to say I've had to radically rewrite my slides this morning because of what was said yesterday. Thank you, Nicholas. Because the things I come here to beg for, you're already doing, most of them. So thank you, guys. And I will talk a little bit about how Go and Haxe interacts. And finally, some hopes and dreams about the future, how this might all pan out. So let's begin with a story about the birth of Go. Go was actually done by three guys who were fed up with waiting for C++ compilations. And the story is that they were sitting there waiting for their C++ to finish compiling, and they thought, what should we do? Oh, blow this, let's write our own language. And since they're at Google and they get, what is it, 1 day a week or something to go and do their own thing, that's what they used that time to do. So this is a quote from one of the three people who wrote Go. Originally, the original design, it's Ken Thompson, who was the guy who originally invented Unix and wrote it originally, so a pretty senior guy. And what I draw your attention to is this part here. There were three of them, and they all had to agree before anything went in the language. And the consequence is that Go is extremely small. And all the good things that people want, and everyone always wants generics, and they never put it in, are not there. So it's a very small language. I've got 3 quotes. Here's my second quote, which is from Robert Griesmer, one of the other in the trio, who was the guy who wrote much of V8, which we were just talking about. So the objectives are reliable and safe, a build system that scales. Google are well into scale, really important, which is why they talk about everything operating at Google scale. And the other big issue is concurrency. So much of what I'm going to talk about now is around concurrency and how to model it. So my final slide is from one of the people on the ANSI C++ committee, who says that now Go is a better solution than C++ for what C++ was originally designed to do. Don't think I need to say anything more, except to do a pretty animation. These guys are gophers. Because it's Go, these little animals are called gophers. And I'll explain how it all works later on. But it's an animation showing how concurrency works. This is written in Go, transpiled to Haxe, and then with some other Haxe OpenFL code, and it's running on Nico. Okay, so it's and what it's illustrating is the way that Go routines allow, which I'll talk about, allow you to do things in parallel, or seemingly in parallel here. So usually when I put this slide up about burning C++ manuals, if I'm presenting to a group of Go people, they all burst out laughing. So you guys didn't, so that's good. So where is Go now, just briefly? It's been open source for 4 years. There's 2 official compilers. Basically, Go is a language specification rather than a compiler. There's 2 official compilers. There's at least 5 unofficial compilers, one of which is mine, and everyone has a Go. You know, it's a bit of a hobby, writing a Go compiler. It's operating live at Google scale. The Google download server is written in Go. Much of the back-end infrastructure for YouTube is written in Go. It's being used in some pretty cool projects. Docker is probably the most high profile, I don't know if you've heard of it. I've just this morning I was tweeting about a new operating system that's just been written entirely in Go. So it's used for that sort of really low-level stuff. And the last conference I was presenting at, there were 800 people because it was a Go conference in Denver. Really big turnout. That was the first conference they'd held. So it's definitely on the up. And just anecdotally, there were IT departments sending their entire team to the Go conference. The entire development teams were there. Okay, so a little bit about comparing Go with Haxe. And I know that Google, who are behind Go, have got a huge budget, and you haven't, so don't take this the wrong way. But there's quite a big difference in the take-up. There's a much bigger audience for Go than there is currently for Haxe, and that's a shame, frankly. And so there's a need for you guys to do a lot more PR to get the message out. And the fact that when Peter was just talking about what tools are there available for writing on the web, the list of tools he put up didn't automatically have Haxe in the list, was a huge shame. Yeah, I'd like to see it automatically there. So, onto the transpiler. And this is my dream, have gophers running around on a handheld device, right? That's what I'd like to have, guys. So, first of all, I want Go running on all the Haxe platforms, which I think I'm there with, as one of the objectives. Then I'd like to have Go able to call the APIs of things like OpenFL, which I'm not quite there with. But so if you want to help, please, I'll ask you for help later. I'd like to demonstrate that Go is viable as an intermediate language for a compiler writer. And So, you know, as that progresses, I'll maybe ask for some more features to go into the language that would help that, or into the libraries. And I'd like to create a viable Go and Haxe mixed programming environment with the idea that people write Go in the server end and Haxe at the client end, alongside the Go code that goes between both sides. So we have Go code that sits in both ends. And finally, I'm hoping to influence both ecosystems to develop in ways that are helpful. So, concurrency. I've whittled on about Go concurrency. Has built into the language as first-class objects are concurrency primitives. And there are two main ones. The first one are Go routines. They are lightweight threads or coroutines, depending on whether you've got one or more CPUs. And that's how you say it. So you have a function name, and in order to make that function run concurrently with your main thread, you just put the word Go in front of it. It's that complicated. And that's it, really. And then for these Go routines to talk to one another, there's this idea called channels. And a channel is a typed synchronous communication, which Go does the thread safe and so on for you. So you do things like send 3 down channel, and read back from a channel. OK would tell you whether there's something there or not on the channel. So I'm just giving you a flavour, really. There's a lot more. So if we go back to this example again, I just kick it running. So each of these gophers running backwards and forwards is running this Go routine here. I should say this is running in Nico. So this is transpiled through Nico. So each of these is running this Go routine, and these little guys running up and down are showing you where they are in that Go routine. Okay? And then what this is, in the middle, the pile of books, that's a channel going between the two. So this is just showing whether there's something in the channel. So there's something in the channel there, that guy was waiting. Yep, so it just illustrates, a way of illustrating how Go routines and channels work. Okay. So how does the magic happen? First of all, you need a Go program. There are some utility, there are inside the Go library, or inside some sort of slightly specialist Go library, parts of the Go library, there's code to take a Go program and put it into the single static assignment form. And that is a relatively standard, or a standard way of representing a program for compiler writers, I understand, although I'm not a compiler writer. And the clever bit the clever bit is that each instruction is really simple and only does one thing, which hence the single static assignment. And that makes it really easy for people like me who aren't clever compiler writers to do things with it, as we'll come on to. Okay, so there's another, so this is in Go, this is in Go. That generates some Haxe, and then we just use the normal Haxe process after that, as you would expect. Okay, so here are there's 36 of these instructions. So in order to make it happen, all you have to do is take each of these, all I do, is take each of these and generate a little bit of code off each, a little bit of Haxe code off each. If you are a compiler writer, you'll be shrieking with horror now because the code I'm generating is horribly inefficient. Anyone shrieking internally and going, oh no, why is he doing that? It's a start. I appreciate there's more that can be done, so, but I wanted to get something up and running before we go on. So here's an example of that. Here's a very simple factorial program. You'll know this from your early years of programming, and this is what looks like assembler, which is the it actually isn't assembler, but it's actually sort of a data structure, but you can render it looking like assembler. So that's the SSA form. More interestingly, though, for you guys, is what comes out of that. So the Go, the SSA, and then what comes out of that is a lot of hacks. And I know you're very interested in that hacks, so after a little while longer, I will go through it in a bit more detail, okay? So you haven't been shortchanged, promise. I thought of doing a live demo, but, you know, I'm really not comfortable with it. So early this morning, I did a live demo to myself, and I took a video of it. So what I'm going hey, thank you. So what I'm going to do is I'm going to run that factorial program we just saw for factorial 10, and I'm going to run it so that it runs on all 6 or 7 of the Haxe targets, and they're all going to run simultaneously. Or they're all going to compile simultaneously. You'll see the results separately. I'll come on to that. Okay, so here we go. Hey, so there's me running. Oh, there's me running TARDIS Go, and the results coming out. The first one that comes out is onto the JS, onto the screen, and then Node.js, Nico, PHP, CS, Java, and C++. Where are you? Yay! And finally, I wanted to show you how big it is, what comes out, and really quite large, I think, is the hacks that I produce. So there's plenty of scope for making it smaller. Sorry, what was in the browser was the Flash, wasn't it? If you know that. Okay. Just to give you a bit of a taste of how Go did that, here's the Go code that did the multiple runs. So again, here we are. I make a channel, which I call results. I range through the targets, and I do Go, target, with some parameters. And then I range around the targets, and I read back the results from the channel I created up here, which these guys are writing to. Okay, so that's how the parallelism is all happening in order to run all of those Go builds and runs simultaneously. Okay? So, some issues. It's just a proof of concept. There's so much more to do to get it to the point where it's really usable, and I'm hoping some of you will give me a hand with that. I had a lot of pleading to do for what I wanted to happen, and it's already been done. It's already planned for 3.2, and that's wonderful. But there are still a lot of issues around concurrency, how to do concurrency on different platforms, and in particular pointers, which Go requires, and some obviously locking semantics and so on. The other thing that, in order for me to entice Go users into using this product, I really need to have the Haxe library actually available to Go programmers, so that they can create Go programs that will run both on the server side and inside the TARDIS Go Haxe environment. So I need to provide a copy of much of the Haxe library, standard library, to inside Go. And I thought I'd just talk about something that irritates me, because I should. And one of the things, just the thing that immediately sprang to mind was, why does it, when you put all F's in there, why does it decide it's -1? Sorry? Fantastic, fantastic. See, you know, what can I say? You guys are marvelous. I just wanted to underline the work that you were talking about with the strings side, and also just to say, really, because I get to put a Chinese character, a Chinese nut, and I get to put a Chinese character on this side, because that's how I decide at runtime whether we're in an 8-bit environment or a 16-bit environment, by looking at the length of the character. It's really important. I'm so glad that's being sorted out, all the Unicode side of things. The only thing I'd say is that inside Go we need Unicode 32, so that's really important. You know, where you have a single 32-bit value that has any Unicode 32-bit type that has any Unicode value in it. Okay, how am I doing for time? I'm going far too slow, I'm sure. Pointer emulation. Really need pointers. At the moment, Go's got a unique approach to pointers. You can only point inside an object. So at the moment, what I'm doing is I have a reference to an object and an offset within it. And that's how I'm emulating pointers. I'd really like to find a better way of doing that because I'm referencing into dynamic types and I'd like to have static types. So my plan is to generate a Haxe type for every Go type and every possible, because I can see through analysis every possible type of pointer there could be and every type there is inside the Go program because it's heavily typed, statically typed. Okay, so Go routines. I thought you might be interested to know how they work underneath. So they're coroutines, which I hope you're all familiar with. Each one is a Haxe class with locals for the variables that are on the stack. The SSA has a block number to show where it is in the flow, and this is used as the program counter. And then Haxe timers and events make that whole coroutine thing operate. I promised to show you the actual code that gets generated for factorial. I didn't show you before because you might think, whoa, that's so much code. You probably still think that. But the point is, you could call this, if you were mad enough, as a Go routine. So you could say Go factorial, and then it would execute it in parallel. So the key, rather than me go through all of this stuff, the key thing here is this set of variables here, which are the variables that form effectively the stack frame for this function. So when you call this function, it pops that onto the stack. Well, where are we? So if we call it from Haxe, it's going to check it's been initialized, and then it's going to make a new stack frame and run it on. Yeah? Oh, sorry, I'm witcher on for ages, forgive me. And then the actual code that runs it, so that was all the setup, the actual code that runs it is here, and you can see it's a ginormous case statement, where each of these elements in the case statement is where the program counter is so far through the Go routine. So when you come back to it again, you can pick up the state that you were in before. Interesting bit to me, I had to create a lot of subroutines, sub-functions. They're useful because you can, if you don't need to have things on the stack, you can create variables, really properly temporary variables. But originally I required them because part of the Go setup is it does a huge initialization process, and for its Unicode processing, I blew up the Java limit on how big a function can be. If you're interested, it's 64K of Java bytecode, which I discovered via this process. Okay, there's some things to do, clearly. I want to improve by using some proper threads to actually, in C++ and so on. And also, I'd like to not implement them. As you can see, there's a huge overhead for using a Go routine because you have to do this coroutine thing, and I prefer to not implement if they don't have to. So if the user hasn't put Go routines in, let's just take them out and directly go to Haxe. So you can call haxlib from Go, not very interesting to you guys, just by putting an underscore in front of it. But there is in order to generate all these definitions with these great long names here, there is some processing to do in Haxe to generate those from the, I think, XML that describes them. All Go globals are pointers. That's just the way it does it. Everything's dynamic at the moment, which needs to change. So here are just the sort of standard ways of getting it to Go stuff by doing loads and stores. And if you want to address into something, then you do an address into to get the pointer value. I'm not happy with calling Go code from Haxe yet. It's not complete. It works fine for functions, but it doesn't work very well when you want to call a method. So if you're calling methods, Go methods, it really is an ugly thing, and I'd like to improve that. Okay, so I'm going to do one last example. So this is the OpenFL Go handling mouse events rehashed to work with Go. Here's the Go program on the right that it's running, which obviously is translated, this time into C++ to run on the Mac. And you can see there's things like this where a mouse event is being read from a stream, so from a channel, should I say. So there's a channel of mouse events happening. And if I just run the video, because I'm too scared not to, to do it live. Please move, there we go. So there's the Go for moving, and as he moves, you can see the state, just to prove it, the status here is changing as the mouse goes up and down, and it processes through here, and finally, woo, we put it in the middle, and OpenFL is wonderful. How Haxe was getting at that is through these calls. So the Haxe calls that were going on to make that happen are here. There's a timer event call that's going in just to schedule on a regular basis to schedule something happening, and then for each of the mouse events there was a call in, just because I thought I ought to show you how the Haxe side of it works. Okay, so I've spoken about Go to Haxe. I'm also interested in Haxe to Go. There does seem to be a project out there that looks like it's inactive that started on this. What Go would give you would be, as a Haxe community, would be a very efficient server-side implementation, very efficient web server that's sort of battle-proven, built into the language, I should say. It's not anything different from the language. And because Go has static binaries, you build the Go, you get one binary, you can deploy it. And that's one of the reasons sysadmins really like it, because there's no system dependencies when you do the deployment. Okay, if it could share a library, it could share the system library, the standard libraries with TARDIS Go, which I've said I really need in order to get the Go community using it. And maybe you might like to think about putting some Go-style concurrency into Haxe. And if you're thinking about that, please let me talk to you about it, because I think it would be a great thing to have. But going beyond that, because I think Haxe would be great as in a compiler intermediate language, and because lying around you already have quite a lot of other things that already translate into Haxe, and you could easily have some more, I think, if you put your minds to it, and certainly if you promoted it. Promoting Haxe as an intermediate language between different compiled languages, I think, would be quite a strong positioning for one of the use cases of Haxe. Now, despite appearances, I'm not an idiot, and I appreciate that you can't, first of all, you can't translate every feature of every language into every other language. Of course, there's only a subset this will work for, and you'll always need to have that caveat. And secondly, it is never going to be as fast as doing the translation by hand. But it might be more accurate, because every time you rewrite code from one language to another, it tends to be inaccurate. And I'll just use a Go case for that. The Go compiler itself is originally written in C, and they're currently rewriting the Go compiler in Go, and they're using this transpilation approach to take their C code and move it into Go. Because although it won't be perhaps as fast as if they did it by hand, it'll be much more accurate. And once they've got a working system, they can make it faster. And I think I think that's quite a strong engineering solution to it. So, always end with a name. Yes. I really need your help to make this work, if you wouldn't mind, guys, at least passively. The TARDIS Go tool itself is written in Go, but there is a tool called Go Haxe Lib, which produces the definitions of the Haxe libraries to be used in Go, which is written in Haxe. And if someone would like to help me with that, that would be fantastic. And of course, if we could get some Go-style concurrency into Haxe, then I'd have a whole lot less work to do, which would be marvelous. So, any questions?
Translate more directly into Haxe code, I mean, for some environments it's going to be a bit tricky because you have to, at some point, have some cooperative multitasking. I mean, like give up control. But you could, have you ever tried like sticking closer to the kind of stuff that is there? Because there are like some continuation passing libraries for Haxe that do look something like reading and writing to these channels, like for example. Have you ever?
I think that's the reason I didn't is ignorance on my part, frankly.
Okay.
And one of the reasons for coming to this event and speaking was hoping that people like you would enlighten me.
So you haven't failed thus far. You just didn't try yet.
I haven't tried yet. Yeah.
Okay.
I mean, I'd really like there to be a better way to do it than the way I've done it.
Mm-hmm. Okay. Interesting.
Yeah? A more, a more efficient way, a faster way would be wonderful.
Okay. Cool.
No specific question, just a few comments. All right, great work. And yeah, further regarding the concurrency thing, I think we were talking about it just yesterday with Koe and different people. And well, that's something we don't have immediate plan for that, but I think we're definitely going to look into this. Mm-hmm. And another thing that we're working on is like have a SSA form for our compilation, for global optimization in the Haxe compiler. Mm-hmm. So we might actually be able to provide either like SSA input for the compiler, so you could, because...
What, so I could translate from the Go SSA form into the Haxe SSA form. Yeah, that would be fantastic.
And, and actually, since the hard part on our side is to translate back our SSA to a proper reduced expression. And that's some things we're still working on. Simon is working on it. But,
well, that would be absolutely ideal. One of the other Go compilers that I was talking about, the sort of renegade ones that are not part of the main thing, are doing exactly what I'm doing. Only they're doing it to the LLVM compiler chain. Yeah. So they're putting out the LLVM SSA form, LLVM bit code.
Well, that's kind of thing we can look into in the documents. Yeah.
That would be fantastic. See, every time I talk about something, it's going to happen, it's going to be fantastic.
Hello. Hey, good talk. I was wondering if there are any other projects that compile Go to another high-level language, like particularly like JavaScript.
Yes, there's a very good project called Go4JS, which takes Go and generates JS. What it doesn't do are the Go routines and channels, though.
Hmm. So it just leaves that completely out?
Yeah, because you can basically, you can, it's almost one for one. You haven't...
Right.
Yeah. So it doesn't have that part of the Go language in it, which many would say would stop it being Go. But, it's actually quite, there's quite a lot of useful stuff you can do with that, and there's an active community doing it.
Mm-hmm. Yeah, Haxe as a language is pretty close to JavaScript, really. So if you have something that compiles to JavaScript, you could use that to pretty easily get to Haxe.
Yeah, yeah. So you could take Go4JS and do that. And indeed, I didn't talk about abstract syntax trees, but if you can take Go to an abstract syntax tree, which is the level before the SSA form, and from an abstract syntax tree, if you're not doing Go routines, you can probably generate Haxe straight off that.
Thank you.
Anyone? Questions?
Well, first of all, it was a great talk.
Thank you.
Congratulations. It was great. So, what I'm thinking, how we could introduce this Go style concurrency into Haxe. How does Go deal with the schedulers? For example, in Haxe, we won't. If you're using a UI, you may have the main thread UI, or but even so, sometimes you even get some more complex with more than one UI threads, or
Yeah.
so how does it deal with that? How do you say I want to run it in this thread, or how does it?
In what I've done so far, you can't. On the main Go implementation, there is a way of doing it by basically by programming in a way where the main thread does all of that. So you write all the main thread becomes the thing that does all the I/O if you've got that issue in your operating system.
It's basically the main thread is the thread that ran the main.
Yeah, whatever it is, you've got to
function.
keep all in one thread. You do in the one place. So the technique is to organise it that way. But that's not really a very, in Go terms, that's not a very strong implementation.
I see. Thank you.
I mean, I should say about these Go routines, it's typical to have 10,000 Go routines running simultaneously. You know, that's, when you're running a large web server, that would just be completely normal. Yeah?
Yeah, and that might be a bit similar to what Scala does with actors, when you have a fixed number of threads, but you can have a lot of actors and they get huge, and then you just have to make sure everything gets run when it's time to. So yeah.
Okay, any other question for Elliott? No, so I think it's time for lunch break.
Okay.
Thank you, Elliott.
Thank you, everybody.